Hello everyone, welcome back to another video in the LLMs related playlist. In this video, I'm going to show you all how you can make the complete pipeline from pre-training till productionizing your LLM, which means you can pre-train your LLM, you can fine-tune your LLM, and you can put it in a real case scenario. From research till real world application, everything will be covered in this video as a pipeline. For this video, I'm considering my LLM as Llama 3 because that is the current best LLM, but this specific pipeline can be adapted for any of your own LLMs, be it Mistral or Phi, whatever you want. Still you can use the same code. That much generic is the code which I'm going to show in this video. Now first let's see the pipeline and then we'll move on to the coding part. So the pre-training to production pipeline comprises of 4 steps or 3 steps, but here I have set it as 5-step pipeline. I'll explain it. Okay. There are some common steps as well. So let's start with that, which is your pre-training. Now people are wondering of how I can pre-train any LLM. Okay. So for this, what I'm going to do is I'm going to say how they pre-train LLMs. For example, there is a paragraph, for example, stating that I am working for neural hacks with Vasant. Okay, so if this is the data, what they would do is they will leave it at I am working. That's all. For neural hacks with Vasant, by loss updation, it will be able to identify. Okay, so that is the core idea of pre-training. This task would be known as next token prediction. Okay, it is known as next token prediction. That is the pre-training task for normal decoder LLM. But if you had been doing something like an encoder model being involved, be it encoder, decoder or encoder, at the time you will do something like mask language modeling. So for example, I'll mask that, put a mask here in some mask here. So it should try to put a location here and then put living in here. Something like that. Okay, if I had saying like Chennai, I am living in Chennai only makes some sense, right? I am living in Chennai, I am residing in Chennai. So these kind of content should be coming up here. So that will be the pre-training task for encoder model, but we have decoder, right? So for this in Llama 3, they wouldn't have specified the data set exactly, okay? But they said that they trained on 15 trillion token high quality data. Okay. And till date, I didn't make any video on pre-training LLMs because such data was not available over internet. But thanks to Hugging Face, now they released a more dataset known as Fine Web dataset. Previously, there were datasets like Refine Web and all, but those weren't good enough actually. So here now, Hugging Face has released this dataset known as Fine Web dataset, which I'll also show you while showing the code. But you can consider that. Again, just have the data. There won't be a lot of pre-processing required for decoder model pre-training. Okay, and considering that it is a high quality data, again, like cleaning kind of stuffs won't be required for you. Next step is instruction tuning, which is also known as SFT. So now, in pre-training, what happens is the model will understand the language. Okay, it will be able to understand the language. But to make it follow your instruction, for example, I'm saying write a summary for the following passage. To understand that, okay, I need to write a summary and then this is the passage. It should understand the context between those, right? Contextually, it will understand from here, but to align to the instruction, to follow the instruction, we'll do the step known as instruction tuning, which is also known as supervised fine tuning. For this, the most popular dataset and the best dataset right now is OpenHermes 2.5 dataset. And guys, I have provided the best pipeline you can get for pre-training by yourself. Again, you would need a lot of computation for this, but if you're going to do any step in this, let's say you have took a pre-training model and you're going to learn from there. Okay, you're saying, okay, Vasant, I don't have resources for pre-training, but I'm going to start from instruction tuning and I'll be doing DPO and then I'll also put it in a real-time application. Well and good. Follow from the second step. Okay, and you're saying, okay, Vasant, I'm not going to do that. I'm going to just do preference alignment, follow from the third step, but the pipeline remains the same. Okay, so here now for this there is open environment dataset, and instruction tuning focuses on a specific concept known as generalization of knowledge. Like there will be tasks for it to accomplish. For example, I'm saying about how to complete a dialogue, and then there is another task of summarizing a passage. So if you ask the model to summarize a dialogue based on the knowledge it has achieved in these two, right, still it will be able to do this task based on the cross task generalization method. Okay, it is known as cross task generalization method. That is something you usually achieve with the help of instruction tuning. So more the task, more generalized the model would be, is the idea. And this was brought by Flantify, one of my favorite LLMs. And if you want to put it as LLM, it is an LLM. And people who are following this channel would know that it is one of my all-time favorite LLM. Now that you have considered, you have completed the instruction tuning itself, you have pre-trained your model, you have instruction tuned your model. Now what? It is not always guaranteed that your model will respond according to whatever it is to be respond. If you are confusing, let's consider this. Let's say I'm asking to tell the model some bad words. Okay, so let's consider this is a bad word. Okay, this is a bad word. Usually when you do just instruction tuning, right, the model will say this bad word, but we'll align the model in such a way that it would say, I am not gonna say something like that. It will be able to identify, to get rid of harmful content from model generating those content, you can use DPO. Okay, this DPO is known as direct preference optimization, and there are lots of other techniques like IPO, KTO pair, but all fall under the technique known as preference alignment tuning. And for this, the best dataset right now available is ultra feedback binarized preferences. Okay, this is the best open source data which is available right now, and you can experiment with that. The next one is ORPO, which is the most latest method and which is said to be better than SFT and DPO. So ORPO, the idea is that the odds of your model generating the correct token should be higher than the wrong token. Okay, chosen rejected. So here what happens is, let's say you have OpenMS data itself with preference. It is not there. Okay, but if you can find such a good data set, right, you can avoid these two steps. You can jump from 1 to 4. Okay, you can jump from 1 to 4 if you have such a dataset, because ORPO expects you to have similar kind of dataset as DPO, but this DPO requires the model to be trained on SFT trainer, or SFT tuning should be done, but SFT is not required in case of ORPO. And the good thing is ORPO is better than SFT. ORPO is better than just DPO also, and ORPO is better than combination of SFT and DPO. But the thing is, you need large data for that. Okay, so you can also think, okay, I'm not going to do second step, third step. I'll just jump from second step to fourth step. That is also good enough. Okay, still that is something you can try to do. Then finally, you have your real-time applications. See, this is a bit complicated because I have just specified two in here, right? I have specified RAG and chatbot, but there are a lot of things you can do. You can do instruction tuning, information extraction, and there is text classification. Everything is there, and it is upon you, like, to make an internet search and all. So I'm just putting it under real-time application because there are lots of tools involved in there. It is more of an architectural changes of the model. Okay, it is mostly building an environment around the model rather than the model being changed itself. Okay, because if you are building a chatbot, if the knowledge is there, if you can make an environment where the model can chat, it will become a chatbot, right? But if you're going to ask that question and it is going to answer, it will become a question answer. Okay, so it is upon you how you convert the model into a real-time application. And there is function calling as well. Okay, with function calling, you can do a lot of things. Right now, Devin and all of these agents are using function calling. So that is also there with real-time applications. And soon I'll also make video on how you can make a very big project with the help of function calling. Already I've made a video on function calling, so if you haven't checked out, please check it out as well, because that is very important right now. So with that being said, that is our pipeline. Okay, so this is the pipeline you should follow for LLMs from pre-training to production. And now we are going to see the code for doing this task. Okay, so here is one notebook which you can follow for the second and third step. Okay, and for fourth step, I have a separate another notebook which you can follow afterwards as well. Now, coming on to this specific notebook. See, the training code, people are wondering, pre-training is different from tuning. No, it is not that actually. What happens is in pre-training, you will have your model weights being enabled. Okay. In fine tuning, the model weights won't be there. That is the difference. Okay, that is the key difference for you to do this task. If you're going to pre-train, make sure that the model weights are randomly initialized or Gaussian initialized based on how the architecture is written, and there is no trained weights in it. And if you're fine-tuning it, the weight should be there. So now you might wonder, okay, that is all fine. Come on to the point. Yes, I'm coming to the point. Don't worry. So here the code is going to remain the same. Okay. So you can provide a training configuration, which will come later. The most important part is I'm setting is pre-training to true. Okay, this is our own configuration, and I'm seeing if we are pre-training. Okay, if it is a pre-training, what you're going to do is you will not call auto model causal for causal LM dot from pre-train, but rather you will just call it with the help of config. Okay, you can also call it with the help of from config. That is also there. That is also possible. Okay, but the thing is, you should not call it with the help of from pretrain, because from pretrain will load the weights and from config won't load the weights. You can see the difference here. Auto model for causal LM dot from config. Let's go here. Auto model. Actually, what happened is Hugging Face for some reason has hanged up actually. I don't know why. So here in auto model for causal LM, you can call it via from pretrain, which is the usual ones. But you can also call it with the help of from config. Okay, when you call it with the help of from config, it will be random initialized weight. All right, that is very important for us. So let's come on to the point again here. So here you can see I'm calling it as from config, and I'm providing the model config here. So for in this, I'm providing the model checkpoint, the vocab size is provided, the max sequence length should be provided for the context length, along with the tokenizer start token ID and end token ID. Now, Llama 3 8 billion isn't a model which will fit in this Google Colab. So for that, what you can do is, recently I made a video on 1-bit fine tuning. Okay, so in there, I would have shown you how you can reduce or change the configuration itself. And I'll also show you now, not this one, just give me a minute. Yeah, here is the code. And here in this, you can see that the dimensions would be changed. Okay, max position embeddings, number of attention heads, these all would be changed. Now, if you are a person like thinking, okay, Vasant, I want to learn from pre-training, how I can do that? All you need to do is, I have already provided this in another GitHub repo, which is for 1-bit pre-training again. Okay, you can just run this configuration extra before calling auto model for causal LM. Okay, here it is Llama for causal LM, but you can put it as auto model for causal LM there. Okay, other than that, is not going to differ a lot actually. Okay, the dimensions, heads, every information are provided here. That is upon you. You can just provide it, but you can follow the same configuration itself, because this is a 70 million parameter model and it will train faster. Okay, so that would be my suggestion. And this notebook is also provided in the GitHub repo, and you can check it out. So what you should do is add the configurations before here. I'll provide a comment here so that you can check it out. Add the configurations for changing the number of layers, heads, and all. Okay, all of those can be done here. Now to change the heads, you can just add those in here and then call the model. Okay, so with that being said, now let's see how you can train this. All right, while pre-training, okay, it is very important that you shouldn't add LoRa. Okay, In pre-training, there shouldn't be LoRa added. You should pre-train from scratch. But while fine-tuning, you can use LoRa. So that's why the use LoRa is inside the else condition and not outside. Alright, that is something you need to note. For pre-training, again, we need a model, we need a data set. All are there, right? So what I'm going to do is, now I'm going to change the configuration like I said. So this is a general data or the code which I have written for fine-tune any LLM video, and we are gonna change that now. I'm gonna do that in live. Okay, all you need to do is change the model checkpoint and dataset. That's all. Nothing other than that. Probably some other things like max steps and all, but other than that, it is gonna remain the same actually. For some reason today, Hugging Face is taking a long time. I don't know why. So I'll put it here actually. Something like you can put the Llama 3 model checkpoint here. You can just fill it correctly. Okay, you can fill it here. And then for the data set name, where I have provided it, I think I've kept it down. Yeah. So what you need to do is you need to change this specific function. Okay. You need to load the data set, and Hugging Face is not opening today actually. So what I did was today Hugging Face is gone down, I guess, the server. So for model, I just identified by going into incognito and then searching it from there. So let's put that in here actually. The checkpoint is not going to differ now. And while pre-training, make sure the load info bit is false. Okay, that shouldn't be true, and that's why we have not provided any of these things like load info bit and all. Please don't do it in 4-bit. Pre-train it in full training itself, or if you wish, you can also do it in 4-bit, because 1-bitnet has shown that you can pre-train it in 1-bit as well. Okay, so that's upon your wish. Still, if you want to pre-train in 1-bit, what you can do is you can follow that video of pre-training and then continue with this specific code. Okay, so load in 4-bit. If you want to pre-train in 4-bit, well and good. You can also pre-train in 4-bit, which is set to true. Other than that, we are also setting the device map to if you are using multiple GPU, right, it should specifically allocate specific layers to specific devices. For that, we are using accelerator, or else you can also provide it as auto. And for torch D-type, we are setting it to float 16. Trust remote code is set to true. Use LoRa is set to true, which means I'm going to use LoRa in fine tuning. Okay, this is a specific configuration which you can use for both pre-training and fine tuning. LoRa alpha, LoRa dropout, all of these parameters I guess you would have known by now. The thing which we should be very interested in is when you are fine tuning, right? Is pre-training would be false. At that time, what we'll do is we'll call the model checkpoint, we'll load it in 4-bit directly, and we'll also attach the LoRa modules. Okay. Other than that, your training argument is provided, which means your training arguments in which your output directory is provided, training batch size is provided, and gradient accumulation steps. In how much steps do you want to do backpropagation optimizer? Like, do you want to use an optimizer which is specifically created for quantized models, which is paged optimizers, paged RMW optimizers, which is what we will use here. And learning rate is provided, learning rate scheduler is also provided. Save strategy, which means how do you want to save by epochs or steps? If it is steps, how much do you want to save? Something like that. And you can play around with these training arguments. I have left it to you. Okay, but while you this is for education purpose, so I've just set the max steps and all. But while you are doing this, comment this max steps and all. Okay, and once this is done, for a SFT trainer, we need the dataset, the tokenizer, the model, and the training arguments all are ready. And here, while pre-training, this will be considered, and for fine-tuning, if we are doing LoRa fine-tuning, this will be considered. Okay. For model, we are providing the model, dataset is we are providing data, which will be called from here actually. The trainer will take data as its input along with the configuration, which was specified here. All right. And we have the training column name. Which do you want to use? Usually I prefer the column name text, and that's upon you. Training arguments, tokenizer, and make sure the packing is set to false, because like if you set packing to true, right? Let's say you have the max length of 512. If there is data of 50 length, okay, 10 dataset will be combined together. So that might at times affect the performance. So it is always better to set the packing to false. And then there is max sequence length provided. And finally, we are calling the train and save model. This is the main function which will first create the trainer, and the create trainer function, once it is executed, the trainer is ready. We'll train the model, we'll save the model, we'll save the tokenizer, and we'll also push the model actually. Okay. Along with that, we're also pushing the GGF model. If you want to push the GGF model, you can also push that. Why I'm saying that is, nowadays inference using Llama is very good, and once you push your model by using this GGF format, right, you can use it with Llama, and I'll also show you how you can use your custom models with Llama actually. Okay, now let's see if the data is ready. Okay, fine, web, it is ready. I think it will again take time. I didn't take. Nice. So actually you did not do anything. Actually, you can just load this data set. That's all. But you can't load this data set here, but you need a very big server is required, because the size, if you see here, it is so huge actually. You should somehow load it. For example, I want to speak about this dataset a bit actually, because it has been said that this has better result than whatever is there till date actually. We'll see about that here. Check the raw version instead. And here they made a graph out of it, and when I saw that, it showed that the model which are trained with fine web outperforms any other model which is trained on any other dataset. For example, C4, refine web, Cosmopedia. In every other dataset, it is outperforming. So you can pre-train with this dataset if you are starting now. And the license also is good actually, open data commons attribution license only, so you can also use it without any consideration. So here all they have provided the text and the URL from where they have taken the text, both are provided. Okay. And the token length is also provided, how much tokens are there in the specific data. So all you need to do is call this data, and already since text is there, all you need to do is just call the load dataset function and just return the dataset. That's all. No need for any formatting. While fine tuning only, you will need any formatting which you require here. Okay. And I have made a lot of videos about fine tuning data formatting and all. Please check those for this actually. Okay. And if you want to do any formatting, write a specific formatting function and then call it here. But while pre-training, this is not needed. Just put the dataset name here. Where is this? Yeah, here it is. Just put it here and call the split is equal to train, but don't run this, your system will crash. Okay, because it is 45 TB, it is not going to survive. But I'm just providing you code so that you can use it at the later part. And for fine tuning, what you can do is just change this dataset and change this formatting and it will work. Okay, now let's say you are completed with pre-training and then instruction tuning. Next you need to do DPO, right? There are not a lot of things which you need to do. The same thing will be there. The model is provided, the reference model is provided, because the same model will provide rewards for itself. That is what is the idea of DPO or any other methods which fall under preference alignment. Okay, but here it is very important that you have an SFT fine-tuned model. And here, if you see, the trainer alone differs. Other than that, everything will remain the same. So I'm not going to explain all of those. And for trainer, we are providing the model, reference model, which will be the same model actually. Okay, LoRa configuration, because we need to train with LoRa. Training arguments, data, tokenizer, these are all fine. Now, these are some things which will differ for you. Okay, first thing is beta. So beta, for specific methods, there are specific beta. For example, DPO, give it a higher beta, 0.5. For KTO pair, give it 0.1 or 0.2. For IPO, give it 0.01. This is the best beta they have found with the research analysis. And for loss type, like I said, there are 3 loss type, which is DPO, for which you need to give sigma, and then there is KTO pair and IPO. Okay, so that is provided here, and based on that, you should also provide the beta. Max length is new or not new, and here, see, they provided a support for aligning encoder decoder model as well. So what you need to do is, if it is an encoder decoder, just set it to true or else keep it false there in the configuration, and make the max prompt length to be your input length. Okay, for example, I'm saying write a paragraph on neural hacks with Vasant. That will be a prompt. Okay, whatever it does after that, will be the expected output, right? So the expected output length is your max target length, and the input length is your max prompt length. Okay, when you combine these together, it will add up to the max length. That is how you need to set the parameters for DPO trainer, and then you can call the same saving functions and all, it will work. Okay, I'll provide this code, and if it shows any error, let me know in the comment section. I'll help you out. Okay, and there is also a Telegram group. Now it is very active. There are lots of people, knowledgeable guys who are chatting it in very actively. So consider joining there as well. Now, like I said, if you are thinking, okay, Vasant, I'm not going to do SFT and DPO, fine, no problem. What you can do is just come to this notebook. Okay, this is ORPO, and thanks to this person known as Maxim Labon, he's an amazing guy. He's one person you guys should follow in LinkedIn. Okay, so for this, again, there are some conventional things which he is doing here, but there are some other things as well. Okay, so these are all to load the model with flash attention and all, which is not required for us. We need to focus on this. There is this one thing which he is doing where he's setting up the model to a specific chat format based on the model and tokenizer. What will happen is it will try to change the model embedding token size. Actually, in one of my previous videos of fine-tuning LLM for information extraction, I would have added some special tokens. Okay, and when I added the special tokens, what will happen is the embedding dimension will change, and the embedding dimension is still 32,000, but the tokenizer length is 32,005. So it won't load, it will give an error. So I needed to call the model resize tokening embedding and all. But here what they have did is, in Hugging Face itself, they have provided this thing called setup chat format, because ORPO adds some tokens inside. So for that, we are providing setup chat format as well, and we are setting prepare model for k-bit training to true, which means when you are calling the function, it will be set to true again, which will make sure that the model is ready for 4-bit or 8-bit training upon your choice. So for this, he has provided a dataset by himself, which is Maxim Labon ORPO DPO mix 40k. You can also choose that, or choose the dataset which I said. Okay, and here he's taking just 1,000 samples, and then the format for DPO or ORPO is that you need to have a prompt, chosen response, and a rejected response. So it will have 3 columns of data, but in SFT or pre-training, just 1 column, which is text. Okay, so he is just formatting the data, and then he will be providing that later. But right now, the configuration, if you see, isn't very much different. The beta will be there, which is 0.1. Other than that, everything is same as before. The thing which is different here is just the trainer and the class name. Okay, previously it was training configuration, training arguments, and then your trainer. Okay, it was SFT trainer or DPO trainer. Now it is ORPO trainer and ORPO configuration. Other than that, the values is same still. Okay, and then finally you can call the trainer.train and save model function. And if you want, you can also again call it merge the LoRa modules, because defaultly it will push the modules alone, LoRa modules alone. You can also load the model along with the LoRa module combined together as a single model and then push to hub as well. That is also possible, which you can execute with these 2 cells. Okay, I tried with executing Llama 3. Like I said, it won't have enough GPU. Okay, that's why I didn't execute this. But if you want, you can attempt as well. That is completely upon your choice. Okay, now we have covered the 4 steps. Now you might think, Vasant, we have done the video, right? No, I'm not going to leave you high and dry in half. Okay, now we have the next thing coming up, which is the 5th step, and it is real world application. Okay, and this is a real world application, which is a PDF bot. Okay, so in this, what I'm doing is I'm using Llama index. I was bored of LangChain, so I just tried Llama index, and it is also same as LangChain actually. Okay, so what I do is we'll take the PDF. Okay, basically we'll upload it here, and then we'll create a temporary directory, because we need file path, not the file itself. Okay, so we'll create a file path based on temp library, and we'll provide that to the simple directory reader, which will read the file. Okay, so we are providing the extension to be PDF, and recursive set to true, because in one directory itself, in subdirectories, there might be PDFs as well. So it is set to true. But if you are thinking, okay, I'm just going to take one PDF itself, so it will also fine. Okay, so you can also provide, if there is no file, you can stop it and then ask them to load the data. Okay, now if the loader is ready, we'll call the load data function from there, which will load the PDF contents. Okay, so once that is done, we'll create the LLM, which is Llama 370 billion, and you need to provide your API key here. Okay, I have already provided mine. You need to provide here, or else for safety, you can also keep it in .env file. And for embedding model, I have used a small env file. You can also use MXBAI, whatever model you think is good, you can use that. Okay, make sure that in settings, okay, this is a parameter of a setting, okay, a variable from Llama index itself. Okay, this setting is a variable which will make sure that this is kind of a configuration thing, and in there we are setting the embedding model to this embedding model. Okay, and for index, vector indexes, we are creating a vector store index. This will be an in-memory vector store index based on the documents. Okay, the embedding model will be taken from here itself. That is why we set the embeddings with the settings here. All right, in LLM, again, in settings we are setting the LLM, and we are indexing with the query engine. Okay, we'll provide the question. Here is a prompt template, and here it takes the context and question. You can just go through this prompt. Okay, and then we'll also update the prompt whenever it is required. Right, when we have the context and question ready, we'll put it in there. For that only we have this query engine.update prompt function. Okay, so once these are done, which means you're ready to chat. So it will display a message known as ready to chat. Will also display the PDF. Okay, we are creating two columns, where in the first column we'll write it as, okay, chat docs with using Llama 3, and in the second column we are just creating a button for clear chat. Okay, because if the user thinks, okay, I'm done chatting with this specific session, I'm going to a new session, we'll call the reset chat function. What it will do is, to keep track of the messages, we'll create a session state and we'll maintain a session state there, and we'll empty the session state. That is what will happen with reset chat function. Okay, so other than that, first we'll get the prompt. Okay, well, that's what is there in the chat input. We'll get the prompt, and based on the prompt we'll run the query engine, and it will give an output, right? So those will be finally created as a message, and those will be appended into the session state. Okay, so that is what happens in here. Again, there is comments for this. You can also go through this code. I'll show you how you can run this code right now. So for this, you need to use Streamlit. Okay, so we are going to use Streamlit to run this, and it is Streamlit. Let me take another environment. Where is it? Llama index env. Yes, and guys, I'll also provide a requirements.txt, so make sure that you create a new environment and run pip install -r requirements.txt. Okay, so let's run this now. Streamlit run app.py. Okay, so let's see if it is running. Okay, no module name, streamlit.cli. Let's see about this. Pip install streamlit. Streamlit process itself not installed actually. Nice. So guys, until this is going as a summary, right? We have seen how you can pre-train the model, how you can instruction tune the model, how you can preference align the model, and now we are seeing how we can make a real-time use case. So in just 40 minutes maximum, I have shown you how you can pre-train the model, how you can fine-tune the model, everything, right? So please hit the like button and share it with your friends, because these kind of videos doesn't exist on the platform, and I can assure you that this is the best content you will get related to this kind of video. Okay, I'm putting my best effort here, and your likes and comments and subscriptions will make me encouraged to push more for these kind of content. And with your likes only, YouTube also recommends my channel to lots of other people. So it's on your hands, guys. So with that being said, again, let me try to run this. Hopefully there is no error. Yeah, there is no error for this. Let's give allow. Okay, right now what is it doing? It's loading actually. Since this is done, let's cut this. Yeah, so here you can see there is clear button and there is text, right? So what we need to do is we need to browse files in here. Let's take something, see if there is something in here. Hopefully it is not an empty document. I'm going to show you all the document clearly in this. So now you can see here there is a resume. Okay, I don't think you will be able to read the content. It is not that big enough to read the content. This is a resume, fake resume created by myself for another video in my second channel. So guys, if you don't know about my second channel, I have a second channel where I'll create AI applications for real world solutions, which is AI DIY Factory. And I know this is a shameless plug, but I had to do it, right? So this is my second channel, and this is the first video in my second channel, which is resume analyzer. I'll build a real-time ATS builder for this resume analyzer. Okay, given resume, it will make a SWOT analysis. So for that only, I created this resume. Okay, and I can ask any question from this resume now. What are the skills specified? And yeah, it has given actually these are the skills, and you can see it is running now. And if you want to use, you can also run it with the help of Llama. All right, that is also possible. And for that, what you need to do is, I'll also show that now. Okay, let's stop this application, cut this out. For this, first you need to make sure that you have Llama installed, and in Llama list you need to make sure that Llama 3 is there. Okay, if you don't have, first do Llama pull Llama 3. Okay, so once that is done, you have your Llama 3 model ready in your system. After that, what you need to do is you need to edit only one line. Okay, I'm not gonna run that because my system is not in a situation for me to execute right now. That's why I showed this with the help of Grok. But I'll show you what is the line to be edited. What you need to do is search Grok. Okay, just comment this line, create LLM equal to Llama of Llama 3. Okay, and for this you also need to import this from Llama index.Llama. I don't think we have Llama here. It's directly here probably. Just give me a minute. And yeah, now you can see, right? There is Llama class here and it will work. Okay, you need not worry about this. If you just call this Llama, you will be good enough to run this. And yeah guys, that's it for this video. I hope you all like this video. If you all like this video, please hit the like button, share it with your friends, and subscribe to the channel. And if you want more exclusive content, because there are some exclusive content coming up for members, so you can also consider joining the membership and support the channel. I'll see you all in the next video guys. Until then, cheers.